In this video, we will continue from where we left off in the Adding Driver and Connection Status video, and we'll complete the feedback and control programming for our driver. We will also load and test the program on our processor. The State Change Event Handler method will deal with all information coming back to our program from the driver. arg1 lets us know what type of information we're receiving, and arg2 is essentially carrying a snapshot of the driver's state that we can read. A switch case on arg1 will help us filter the feedback where it needs to go. The cases are automatically generated from the display state object enum when arg1 is entered as the evaluation and the down arrow is pressed. Once we know the case that raised the event, we can use arg2 to provide the appropriate feedback for our panel. Here we have targeted the description of the currently selected input in order to drive the appropriate feedback. For controlling the device from our panel, the process is no different from any other device. We're using an enum to hold our panel join numbers so that when we program our panel sig_change method, our switch case is built for us. Within each case, we then access methods within the driver to trigger sending the commands to the device. Once all button presses have their associated command for the driver, we compile, load, and test. We have set our driver to connect on program load, therefore we did not see the alternation of the connection status. We can see on our emulator that the feedback is showing 2, which is connected. Our first test will be to confirm our connection status to the panel is being updated. We will do so by restarting the program on the emulator. We briefly see disconnection status followed by a return to connected. And in the CP4N console output, we can see our console print line statement showing this state change. Testing further with our commands, we first issue power on and see the emulator receiving and responding. And we see the original print line statements remaining in the driver about the incoming message to the driver. Our power is on status shows that our code in C# implementing feedback from the driver is functioning. Similarly, with power off, we see the response in the emulator and we see our feedback go low. Now, the way our driver is configured, we are unable to send other commands to the device while the device is showing powered off. Turn the device back on again, and we are receiving our feedback. We are then able to issue our HDMI selection commands, noting the emulator sending and receiving, and our feedback updating appropriately. Now that we have issued all of our commands, our testing is complete for this stage of the driver. Thanks for watching.